In this lesson, I'm going to show you how to calculate the harmonics in air columns. We have two questions here. We have an open air column and a closed air column. So let's look at one at a time. In the first case, we have an open air column which has a length of 75 centimeters. So this length right here, we need to convert that to meters. So 75 centimeters is equal to 0.75 meters. Okay. Since this is an open air column, we use the equation for the open air column. Fn is equal to nv over 2L. In the open column, this number right here is 2. So for the first harmonic, we would have F1 is equal to 1, n is equal to 1. The speed of sound is 341. Let me make a note of that here, that V sound in air is equal to 341 meters per second. Since this is an air column which is vibrating, it would be appropriate to use the speed of sound in air. So back to our formula. F1 is equal to 1 times 341 divided by 2 times L. And we plug those numbers into a calculator and we get 227 hertz. So that's the fundamental frequency, or the first harmonic. It asks for the first two audible harmonics. So we can use the relationship or the concept that harmonics are whole number multiples of the fundamental frequency. So if we're interested in the second harmonic, that's going to be equal to 2 times the fundamental frequency, 227. So F2 is equal to 454 hertz. Good. So these are the first two harmonics, audible harmonics, of this open air column. For a closed air column of 75 centimeters, that's 0.075 meters. For the closed formula, we would use Fn is equal to Nv over 4L. We use 4 in the closed formula. So F1 is going to be equal to 1. We're calculating the first harmonic times the speed of sound in air, 341, divided by 4 times 0.75 meters. So the first harmonic in this closed tube is going to be equal to 114 hertz. What's interesting is that when you have a closed tube versus an open tube of the same length, in the closed tube you have a lower frequency than in the open tube. Now, we need to find out the first two audible harmonics, and I need to make a note here. In a closed tube, only odd harmonics are audible. Only the odd ones are, we can only hear the odd harmonics. So that means we can hear the first harmonic, the third, the fifth, the seventh, etc. We can't hear any of the even ones. So that makes 3 the next audible one. So we're going to use this same formula here. Fn is equal to nF1, but we're going to jump to the third because the second one is not audible. So 3 times 114. So F3 is equal to 342 hertz.